Alrighty, everybody, welcome to our 4:30 live stream of Tour of the Universe, hosted at the Morrison Planetarium here in the California Academy of Sciences in San Francisco. Uh, Really quickly, I just want to introduce myself. My name is Christian. I want to be your planetarium presenter. I'm very excited to have y'all here today. Just to let you know ahead of time, right now the Morrison Planetarium is closed for its yearly maintenance. So there's a couple of times throughout the year where we had to close the planetarium so that we can make sure that it's up and running because it's running all the time. So it does require some days off. And right now, I'm kind of doing the show from a little bit of a different location off our laptop. So if things look a little bit choppier than normal, then that's going to be the reasoning. But we still have some really great laptops and computers, so we're still able to do our live stream here. But once again, my name is Christian. I want to be your planetarium presenter. And also, I kind of want to add to it. This show is going to be a little bit different since I don't have a normal live audience than I would normally do in the Morrison Planetarium. So we're able to do a little bit more fun. So if you have any questions throughout the show, feel free to type it in the chat box. I'll try to answer it the best I can. But just a reminder, I'm a human, not a robot. I don't know everything. Maybe my moderator could answer some questions if I don't know it. But again, if you have any questions, feel free to throw it in the chat and we'll see if we can figure it out together. And again, this show runs about 30 minutes, maybe 25. So we have some time for some questions along the way. But we're going to be starting off here pretty close to the Earth. We can see all the city lights down below, and we're starting at this spacecraft right in front of us called the International Space Station. And a lot of people tend to ask me, hey, Christian, what is the International Space Station? I hear about it all the times in news and articles, but I don't really know what it is. Could you explain it for me? Well, of course, folks. The International Space Station is a research facility, a laboratory that orbits around our planet Earth. And they're able to conduct a lot of different types of science experiments that they're unable to do closer to to the planet, which has a lot more gravity. So some of the different types of science experiments that they'll conduct here at the International Space Station are things like what happens when you try to grow plants in space? Do the plants grow the same? Do they grow differently with less gravity? Which way do the roots grow? Another experiment is what happens when you try to spark a match in space? Does the flame act the same? Does that act differently with less gravity? And one of my favorites is that they did here at the International Space Station is with two identical twins. One twin lived on Earth for about a year. The other one lived on the International Space Station for a year. After that year, they compare and contrast the two twins. Turns out when you live in space for a long period of time, you tend to age a little bit slower. But not only that, you also lose a lot of body mass index because you don't have gravity constantly working down on your muscles all the time. So if you plan to live in space for a long period of time, remember to exercise daily. Hee hee hee. And also, folks, I want to let you know that the International Space Station looks really big here on our screen, but in actuality, it's not that big. It's only about the size of an American football field. So if you've never been to an American football game, but you've been to the California Academy of Sciences, that's about how big it is, about as big as the museum that I'm at right now. And also, what's really fascinating about the International Space Station is that this thing is going incredibly fast, folks. The International Space Station is traveling at a whopping 17,000 miles per hour, where it orbits once around the Earth every 90 minutes, where it experiences 16 sunrises and 16 sunsets a day. Whew, how romantic. And also, this looks really far away from our planet, but the International Space Station is only about 225 miles above the surface of our world. 225 miles, that's not too bad. That's like going from San Francisco to Santa Barbara, a nice little road trip to get away with the family for the weekend. So, not too bad. Only 225 miles above our world. But, folks, the International Space Station is just the first stop on our tour of our universe. So, we're going to be leaving our world behind. In fact, let me reorient ourselves a little bit. And so now we're going to see it start to slowly disappear to the city lights down below. And also, I forgot to mention what our tour of the universe is about. I got excited with our new setup. With tour of the universe, we're going to be starting off pretty close to the Earth, and we're going to be zooming all the way out to the very edge of the known universe. So hopefully, by the end of the show, you won't have an existential crisis. Hee hee hee. In fact, we have already lost the view of the International Space Station, and I want to add a nice little orbital path so we can see it. There it is with that nice little orange line. And now we're slowly getting a much larger view of our world. Alrighty, folks. So now we've zoomed so far away, and we're now able to look at our entirety of our planet. And I want to let you know that the space program that I'm using right now is something, the same program that we use in the Morrison Planetarium, and it's something that you can download and try out at your house if you like to give it a try. The space program that I'm using is something called OpenSpace. So if you go to your favorite search engine, type in OpenSpace Project, you'll come across a link where you can download this, and it's a whole lot of fun. But I do want to let you know that OpenSpace takes a lot of processing power because this is an open source program, so it uses a whole lot of processing power. So if you have an older computer, I wouldn't recommend downloading it. It may overwhelm your computer. Also, OpenSpace uses a whole lot of memory space. So if you don't have that memory space, maybe reconsider. But if you've got all that and you want to fly through space, give it a try. It's a whole lot of fun. I also want to let you know that OpenSpace is in its beta phase, which means that it's not completely finished. So we may come across a few bugs and glitches. If we do, I'll point them out for you, and hopefully we can look past them. And also, we also have another great alternative aside from OpenSpace. Personally, for me, I'm not the most tech savvy person, so honestly, I'm not the best at downloading things. But we also have another great alternative called NASA's Eyes. Just like the human eyeball, type in your favorite search engine, NASA's Eyes, and you can find a link where you don't have to download anything and you can fly through space, and it's so much fun. But again, the two space programs are Open Space Project and NASA's EYES. But now that we got a good sense of what we're using here, let's make our way over to our nearest natural neighbor to us in space, the moon. So let's shift gears and fly over to our nearest satellite. And I do want to let you know, folks, that we humans have been to the moon before, but that was a little while ago. That was between 1969 and 1972, thanks to NASA's six Apollo space missions that brought a total of 12 incredibly lucky guys to walk on the surface of the moon. They got to conduct science, and of course, they had some fun up here as well. They got to play some golf. But again, last time we sent humans to the moon was 1972, a little more than 50 years ago or so. But don't worry, we humans are planning to make a return trip back to the moon in the next few years, thanks to NASA's new space mission in the works called Artemis. Pretty much with Artemis, NASA wants to send humans to Mars, but before we send humans deep into our solar system, we got to figure out exactly how we're going to be living out in space. So the moon is the perfect stepping stone to figuring out the logistics of how we'll be living all the way out here. And what's also really cool about Artemis is that NASA is going to be sending the first woman to the moon. But not only that, they're also going to be sending the first person of color to the moon. But not only that, they're also going to be setting up lunar bases throughout the moon. Pretty much our technology has greatly improved in the last 50 years. So we're able to do a lot more science in a much more compactable size. And we want to check out things that we weren't able to check out 50 years ago. One place that we definitely want to set up a lunar base is the south pole of the moon. The reason why is because we've come across a good deal of ice, a lot of ice, and ice is going to be very helpful for setting up a lunar base because you can melt that ice, which is water, and then you can pass an electric current through it, and that separates the H2O from each other, so you get some oxygen and you get some hydrogen. So those are both very helpful. And also, we want to go check out some other places around the moon. Maybe we want to go look at the deepest part of the moon, which is an Aiken Basin crater, which is on the far side of the moon. Or maybe we want to go take a look at some areas that we weren't able to check out 50 years ago. But again, we humans should be heading back to the moon in the next few years, thanks to the new space mission by called Artemis. So look out for anything about that in the news. And also, folks, when we look at the moon here from Earth, the moon sometimes feels really, really close to us. It feels like you can reach out your arms and touch it, especially when it's close to the horizon. But the moon's actually really far away. It's only about 240,000 miles away from the Earth. Whew, 240,000 miles. Some of the adults that are watching this show right now probably have a car with that many miles on it. And if you take better care of your car than I do, you can even imagine driving to the moon if you drove for about 4 months nonstop, going about 80 miles per hour. Although I wouldn't recommend it. The roads out here are poorly maintained. Hee hee hee. And folks, from here on now, we're going to need to use a more useful measuring stick because at this scale, using miles is kind of like using inches to describe the distances between cities because space is so big. So astronomers use a more convenient measurement known as light speed. And light travels at a mind-boggling speed of 187,000 miles per second. That's roughly about 300,000 kilometers per second. So while it took the astronauts more than 3 days to reach the moon, traveling faster and farther than any human has done so or since, it only takes light 1.5 seconds to cross that distance at the speed of light. That's kind of like a short pause in conversation, so not too bad. But at last, it's time for us to leave the moon behind. So everybody say, bye bye, moon. We'll see you later. So now we're going to start to see the moon and the earth and their orbits start to slowly disappear. In fact, before we lose track of the moon and the earth, I want to add some nice little planet trails because, again, space is so big, you can lose things out here very easily. So let's see. We got some nice trails coming in. Hmm. Give it a second. Looks like my computer is thinking about these trails. Okay, maybe OpenSpace didn't like my trails. We're gonna give it another few more seconds. Hmm. And one moment, folks. Let me see if I can test some things out real quick. Ah, there we go, folks. For some reason, when I hit the planet trail button, it threw me into the moon. All right, I am completely sorry about that. And again, sometimes it's a little bit glitchy, but again, hopefully we can look past that. And thank you for sticking around. I really do greatly appreciate it. But again, we're now watching the Earth and the Moon as they start to slowly disappear. And now, folks, on our journey, we're going to be traveling much faster than the speed of light. We're going to be traveling at the speed of the human imagination, thanks to the help of computer models like OpenSpace, like we're using right now, to show us the most accurate images and information available to us. And now, the nearest star to us, the sun, should be coming into view. So, here comes the sun. Do 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 do. So we can see our sun right over there. And just to let you know, folks, our sun is really, really far away from us as well. It's about 93 million miles away from the Earth. Whew, 93 million miles. That is a good distance away. Now, again, we're the third rock from the sun. So if we count it out, we got one, two, and three. That's us right over here. 93 million miles between us and the sun. In order for sunlight to travel that 93 million miles, it only takes sunlight 8.5 minutes at the speed of light to travel that distance. Only 8.5 minutes. That's not too bad. But now that we have a nice bird's eye view of our solar system, let's do a quick refresher of what we have here because there's a lot of good stuff. Right in the middle, we have our sun, our star. And then the closest planet to the sun, we've got Mercury right over here. Then we have Venus, sister planet. And then we have Mars. That's us. And then over here, we've got, or well, we have Earth, and then we have Mars, the red planet. Sorry about that. And then past Mars, we have this really cool thing called the main asteroid belts. And this is what it would look like if we were to highlight all the asteroids in our asteroid belts. There is a lot of them. So all those green dots represent asteroids in our asteroid belts. And then past the asteroid belt, we have the really big planets, the gas giants, the Jovians. We've got Jupiter, the largest of them all. Then we have Saturn, famous for its rings. And then past Saturn, we have our icy gas giants. We've got Uranus, the funny one, and Neptune. And of course, we can add everyone's favorite and lovable dwarf planet, Pluto. So here comes the orbit of Pluto on screen. Hopefully, I don't get flung into the moon again. Let's see. There we go. So here's Pluto on screen right over here for you folks. And then a lot of people don't realize that Pluto hangs out here in this outer part of our solar system called the Kuiper Belt. And you're probably wondering, what's the Kuiper Belt? Well, folks, the Kuiper Belt's going to be all this stuff. So the Kuiper Belt is like a second asteroid belt. What you're mostly going to find out here are mostly icy asteroids and short period comets, comets that don't stray too far away from the sun. They have a nice short period like so not too far away. And again, this is like a second asteroid belt. And in 2006, we found more than 400 objects out here. And the reason why is because our telescopes greatly improved, and our telescopes were able to see smaller objects much further away. And that's the really cool thing about science, because as our technology gets better, we're able to see much smaller objects that we weren't able to see before. And who knows, maybe in the next 10 to 15 years, as our telescopes get better, we'll find more stuff out here in this outer part of our solar system, which just sounds so cool to me. But I want to put away the Kuiper Belt because that's just a lot to look at. And right now, I'm going to be adding on screen some many different spacecrafts we sent out in the 1970s to explore our solar system. So on screen right now, we have the trajectories of Pioneer 10, Pioneer 11, Voyager 1, and Voyager 2, and the latest of them all, New Horizons, which did a quick flyby of Pluto in 2015. We can see that interaction right over here. Did a flyby in 2015. Now, just to let you know, all these spacecrafts are all traveling fast enough to escape the sun's gravity and leave our solar system behind. But even the most distant of these robot adventures, Voyager 1, has not traveled as far as light travels in a single day. In order for sunlight to travel all the way out to the orbit of Pluto, all the way out here, takes sunlight about 5 hours at the speed of light. 5 hours. Whew, not too bad either. But now, folks, we're going to be leaving our solar system because now we're going to be heading into interstellar space, the space between the stars. Distance now becomes so immense, it's going to take us about 4 years at the speed of light just to reach the next star system to us, the Alpha Centauri system. And I always want to make sure that I'm getting the right star system because there's a couple of them nearby. And Alpha Centauri, so we're right here in the middle. Alpha Centauri is going to be this one right over here. Again, 4 years at the speed of light just to reach the next star system to us. But that doesn't really put into perspective of how long it would take us humans to travel that distance. Well, folks, if you're getting a spaceship today, left planet Earth, make your way over to Alpha Centauri. It's going to take you about 8,500 years to cross that distance. And that's just a one-way trip. Whew, I wouldn't want to take that road trip, to be honest. He, he, he. But, folks, let's stop and consider whether humanity has made its presence known beyond our solar system, because now we're going to be stepping inside something called the radiosphere. So, again, we're now inside something called the radiosphere, and this represents the current limits of the most distant radio signals humanity has ever broadcasted, or rather leaked into space. And it extends about 90 light years in all directions, emitting out from the Earth. And this began in the early 1930s with strong radio waves, early television, radar signal, and then later the detonation of atomic weapons. All this stuff is emitting electromagnetic radiation strong enough to escape the Earth's ionosphere. And humans were broadcasting well before that, but the earliest radio was not quite powerful enough to escape. And since all these signals are electromagnetic, they are traveling at the speed of light. So this is kind of like humanity's electromagnetic footprint in the universe. And of course, the radiosphere is constantly expanding at the rate of 1 light year per year. So is anybody out there listening? And right now, folks, I'm going to be adding some many markers onto our screen. So here comes those markers. And these many markers represent some of the many thousands of stars astronomers have discovered over the last 30 years, which has at least one or more planets orbiting around them. We call these planets exoplanets, and we're looking for any of them that are Earth like with conditions suitable for life as we know it. So far today, we found 5,000 confirmed exoplanets just in the nearby vicinity to us. 5,000 other worlds besides our own. Whew, that is a lot. And that 5,000 number is going to be increasing as the years continue because we have space telescopes where their whole purpose is to find as many exoplanets as possible. So if we look right over here, you'll notice that those space telescopes just looked in this one region of the night sky and found a whole heap of exoplanets. So again, as it continues to scan more and more of the night sky, more exoplanets will be found. Now, to say if any of them are Earth-like with conditions suitable for life as we know it, well, we can't answer that question quite yet. Pretty much new space telescopes are being developed right now, so it's going to be a few years before we can answer that question because they're on the drawing boards. They have to be constructed, launched into space, and then of course we gotta go through the information. So we got a little while before we can answer that question. But the more important point here is that quite a few of these planetary systems are within the 90 light year limit of our radiosphere and could have potentially received our signals. However, since radio waves travel at the speed of light, if there is anybody that's out there able to listen in and answer back, the communication delays between hellos could be decades in time. Now, to give you an example, let's say we live in this star system right here. We find an alien civilization, let's say somewhere over here on the right side. We say, hey, we live here. We shoot them a text message. Take 60 years to get to them. They listen in, answer back. Another 60 years. Folks, that is a 120-year conversation in the making. Whew. And I can barely wait for a text message from my friend. He he he. But of course, planetary systems beyond the radiosphere, more than 90 light years away, have not heard from us yet. But eventually they will, as the radiosphere is always growing, but it becomes weaker as it does. But for now, I'm going to be putting away those exoplanet markers away. But I'm going to leave our radiosphere up on screen. As huge as humanity's electromagnetic footprint is, it is nothing compared to our Milky Way galaxy. So let's continue zooming out and get a better get a better idea of where we are. And let me just swing us around. And now, folks, we're looking down on our Milky Way galaxy. This is the galaxy that we live in. And I've got to ask, can anybody see their house from here? Just kidding. I can barely see our radiosphere right over there. And just to let you know, folks, our Milky Way galaxy is incredibly large. If you wanted to cross it from one side to the other, it's going to take you about 130,000 years at the speed of light to cross our Milky Way galaxy. This thing is really, really big. And not only that, our Milky Way galaxy is so huge, we estimate that there's at least 300 billion stars in our galaxy alone. If a recent discovery of so many exoplanets just within our small neighborhood within this vast star city is any indication, there could be billions of planets and potentially millions of Earth like planets throughout our single galaxy. And before we leave our Milky Way galaxy, I want to show you something, what it looks like from a sideways perspective. When we look at the Milky Way from this angle, you're going to notice that we live in a big flat spiral disk, just like so. And you probably looked up into the night sky and you probably heard someone say, hey, look, you could see the Milky Way from here. What they're referring to is this. That's what you're seeing up in the night sky, the plane of the Milky Way galaxy. And this is important because when astronomers and scientists want to learn about the universe, it's so much more easier for them to point their telescopes galactically north and galactically south instead of looking through the plane of the Milky Way, which has planets, stars, gas, debris, things that block their view of the universe. So keep that in mind. Astronomers and scientists like to point their telescopes galactically north and south. That's going to come important in just a little bit in our show. But folks, the Milky Way galaxy is only one of many hundreds of billions of galaxies that comprise our known universe. So in this giant leap, every single point of light that you're now going to see no longer represents a star. Instead, it represents the location of an individual galaxy. Each galaxy containing hundreds of billions, perhaps trillions of stars. Now, we live in a local galaxy group which contains about 30 galaxies, large and small. Also includes the nearest large spiral to us, the Andromeda Galaxy, only 2 million light years away, just next door, and heading right for us. We're going to get to know it pretty intimately in about 5 billion years, so mark your calendars. And folks, as our picture continues to expand, you're now going to realize that galaxies are not evenly distributed throughout space. Instead, galaxies like to clump together in large groups and clusters, or they like to avoid each other where there's very few galaxies or no galaxies at all. So you can see a nice galaxy cluster right over here. We can see some nice galaxy clustering over here. We can see very few galaxies on the top right or no galaxies at all. You can kind of think of galaxies like people. They like to hang out together or they like to avoid each other. But folks, we've zoomed so far out now that this picture that we're looking at represents the closest 30,000 galaxies to us in a space over 300 million light years across. We got to give thanks to an amazing astronomer by the name of Dr. Brent Tully, uh, who worked at the University of Hawaii, who created this amazing representation thanks to work of other astronomers working beside him over decades of time. So big shout out to Dr. Brent Tully. I love flying through this map. But now, folks, we have automated systems that are mapping even the most distant galaxies. So now we're about to see the very large scale structure of the universe. And remember, every single point of light that you're seeing, that's not a star, that's an individual galaxy. Whew, I feel small. And just a reminder, or just to let you know, the large scale structure of the universe is not in the shape of a bow tie or a butterfly. Remember when I mentioned that we live in the flat spiral disk of our Milky Way galaxy? Well, if we were to line up our Milky Way galaxy, it would line up just like so, right down the middle. So again, we like to point our telescopes galactically north and galactically south. But astronomers still wanted to make sure that there was galaxies to the plane of the Milky Way galaxy, so we had this nice purple survey right here, and they were still able to find galaxies, just not as many and not as far. Pretty much, we have to wait for our technology to get better, and once that happens, we'll be able to fill in all these areas that haven't been filled in yet. So it's just a matter of time. And unfortunately, folks, 30 minutes has come by really quickly and fast, so we're running short on our tour of the universe. So let's continue pressing on because we still have a little bit of ways to go. And now we're going to be encountering these really distant, far away objects known as the quasars. And the quasars are going to be these orange dots that we're seeing here on our screen on the left side and the right side of the large scale structure of the universe. And quasars are short for quasi-stellar radio sources. And these blazing objects are all billions of light years away. So now we're looking so far back in the depth of time and space that the most distant quasars represent the universe at a much earlier age. We're nearing the very beginning of galaxy formation. In other words, with the quasars, we're viewing a sort of awkward, gawky, and teenage version of the universe. And before there was a teenager, there was a baby. So let's press back to a time before quasars, before planets, stars, and even galaxies began to form. Folks, we're about to see the very edge of the observable universe. And here we are, folks, at the very edge of the observable universe. And what we're looking at is something called the cosmic microwave background image, or the CMB image for short. All evidence indicates that the universe that we live in is about 13.8 billion years old. And this is data compiled by Planck and other radio telescopes. And the picture that we're looking at is a very baby version of the universe, only 380,000 years after the Big Bang occurred, where space and time began. And this isn't a typical photo either. Instead, this is a temperature density image, where the light echoes of the Big Bang are color coded, where the lighter areas correspond to the hottest, least dense regions, and the darker areas the coolest, densest regions. These fluctuations in temperature and density are extremely, extremely tiny. They vary no more than 1 part per 100,000. But these really tiny differences eventually gave rise to the large scale structure of the universe that we saw moments ago, that clumping and clustering of galaxies everywhere. Figuring out just how that happened is one of the larger challenges for cosmological research today. Though our view here is of the outer edge of the known universe, folks, the earliest light visible to us, that radiation actually persists all around us. It permeates the universe, stretching and cooling as the universe expands over billions of years of time. But folks, we've traveled as far back as the law of physics can physically allow us to go, so we only have one direction left to go, and that's going to be back towards planet Earth. That's home. So we're going to find a nice entry point through all these quasars and galaxies. And this looks like a good spot. And let's make our return trip back to planet Earth, folks. And again, folks, we're across an expanse of over 13 billion light years. We present you with this view of our universe and the latest in cosmological and astronomical information. We're covering eons and observing objects billions of light years apart. Now, we live in a golden age of astronomy with new generations of telescopes and spacecrafts that are extending the reaches of our eyes, preparing for the eventual race between the advancement of technology and the accelerating expansion of the universe. And with that thought, I want to remind you all that astronomy is for everyone. You don't need to be a rocket scientist to enjoy the beauties and wonders of our universe. All you need is the night sky, and if you can, get away from the lights of our cities and look up. Even a good pair of binoculars makes for a decent first telescope, and there's astronomy clubs all around the world that invite people just like you to peer into their telescopes and see into the great beyond, allowing you to partake in the wonders that our universe has to offer. Now, astronomy as a hobby can offer an endless supply of satisfaction, and I do hope you'll join us, those who dream amongst the stars. But it looks like we just made our way back into our Milky Way galaxy. We're heading straight to that radiosphere. And now we're approaching our star system, our solar system. And now we're about to pass the spacecrafts we sent out in the 1970s to explore our solar system, passing the Kuiper Belt in the orbit of Pluto. And we're making our way to the third rock from the sun, our homeworld, planet Earth. All the people that we know and love all lived on this planet. Everybody that we know and learns in history all lived on this one world. And now, folks, we're about to pass the orbit of the moon, the furthest we've ever sent humans out into outer space. And now we're making our final approach back to planet Earth. And with our final approach, folks, this is going to be the end of our Tour of the Universe show. And I want to thank y'all for stopping by and watching it with us today. I hope you did enjoy it. But hey, look at that. We made it back safe and sound back to planet Earth. And that's all for today, folks. Thanks for stopping by and thanks for sticking with us. We greatly appreciate it.